Okay, so chapter 5, polynomial functions. In the first two sections, we're going to look at the polynomial functions and their graphs. And then the second two sections next week, we're going to learn how to find roots of those polynomial functions through some various techniques. Polynomial looks like this. I know I sometimes write this kind of stuff and people are like, I have no idea what all of that is. But just understand that this a sub n, the a sub n minus 1, those represent coefficients. And these are the numbers that come in front of the variables that you have. The variable here is x. And so this n, the n minus 1, and so on down the line, those are subscripts. And they are just a different way of looking at what that number is. It's identifying or delineating between different a's. Now these coefficients can be any real number. Okay? The n's, however, those are the exponents that we have on our x's. And these, by definition of a polynomial, those have to be natural numbers, or the counting numbers, 0, 1, 2, 3, so on and so forth. So there's no fractions here, and there's also no decimals here. So the points that we're going to be interested in, much like when we had with quadratics, when it comes to polynomial functions, is we're going to have the y-intercept, and then we're going to also have roots. Now these roots are just solutions to the polynomial, just like we did with our quadratics. These are the points where it crosses the x-axis. And finding those, we're going to use polynomial long division, and then actually use synthetic division to find those, and we'll learn about that next week. The other parts we're going to look at is where does it go after it's done crossing the x-axis. Is it going to go to negative infinity or positive infinity as it goes to negative infinity in the domain? Or is it going to go to positive infinity or negative infinity as the domain increases to positive infinity? Every single time you're going to get graphs that either look like this, where they start negative and go positive, or they flip around like this, or they're like this, or they're like this. And I have a video that talks about end behavior. And when I mean end behavior, what's happening at the ends of our polynomial. Now, one thing that we could find with quadratics that we can't with polynomials is finding these relative maxes or mins. That's beyond our capabilities for pre-calculus. To find those, you would use calculus to make that happen. So we will use calculus to find those relative max or min values, okay? We can estimate what they are by looking at graphs, but in order to find what those are exactly, you do something in calculus called take the derivative. And you set that derivative equal to 0, and that's differential calculus. Okay?